Welcome back. You've learned the first method of solving a system, the graphing method, in the last lesson. In this lesson, we're going to talk about the second method, the substitution method of solving a system. So let's review what substitution means. It's a word you've heard a lot, but let's really define it. So substitution is the act of replacing something with an equivalent value. Okay, we substitute a lot of things in life. When we're cooking, we can make substitutions, right? We can use wheat flour or regular flour. We can substitute lots of things in real life. So we have substitute teachers, right? If I'm absent, you have a substitute come in for me. So we can do the same thing in math and same thing with a system. So I'm first going to show you this system right here. So here's one system, the y equals 2 and x plus y equals 6. And I'm going to show you both ways. I'm going to show you solving by graphing and show you solving by substitution. So let's go ahead and graph this first, y equals 2 in red. Noticing that there is not a second variable in y equals 2, so that's going to be a horizontal line at 2. So here's y equals 2. We're going to have a horizontal line going straight through that, like that. Then I'm going to go ahead and graph this blue line. Now notice that y is not alone, so we're going to have to subtract the x on both sides. And we end up getting y equals negative x plus 6. So let's graph that. That's now in slope-intercept form. So I'm going to start my point at 6. There's an invisible 1 right here. I'm going to put in pink. So that's an invisible 1 over 1. So that's my slope. So I'm going to go up 1 over 1 to the left because the slope is negative. I'm going to make points and see where they intersect. And I can already see on the line the place they intersect. Let's make this nice and straight. And I can see with my highlighter that this is the point of intersection right there. And this is what we learned last lesson. So I know that my solution, that point is at 4, 2. But what if I didn't want to graph it? What if I wanted to use a different method of solving this algebraically? I don't have a grid, I don't have a graph, what can I do? So substitution means replacing something with its equivalent value. Well, in this case, I know that y equals 2. If y equals 2, I can go ahead and replace the y in the other equation. So instead of x plus y equals 6, I'm going to have x plus 2 equals 6. I'm replacing this y that I'm highlighting with the 2. I'm substituting it in. Now I can go ahead and simplify. We can drop the parentheses and just have x plus 2 equals 6. Subtract the 2 on both sides and get subtract 2 on both sides and get x equals 4. Notice that that is what I had when I graphed. X is equal to 4, x is equal to 4. So I got the same thing. Okay. Also notice that y equals 2. So if x equals 4 and y equals 2, I have a point at 4, 2. Both options give me the same solution. Okay. And sometimes substitution is a lot easier than graphing. Okay. So let's take a look at a different example. Now I've got a system where it's y equals 4x. It's not just y equals a number, y equals some expression. I'm going to do the same thing. I'm going to underline that y is equal to 4x, and I'm going to plug it into the y in the other equation. So here's my y, and I'm replacing it with 4x because it's equivalent. So now I'm going to have 5x, keep the 5x plus 2, and in parentheses, I'm going to replace it with that 4x. Oh, let me write that a little nicer. 4x. So I'm substituting the 4x in for the y because they're equivalent. Now you're going to go ahead and, like we did earlier in the semester, solve this equation. So I'm going to have 5x. 2 times 4x is 8x. 5x plus 8x is going to be 13x. Equals 39. And when I divide both sides by 13, I get x equals 3. Okay. Now that I know x is equal to 3, we're not done because I need a coordinate pair. Every system has 2 solutions. So you're going to have 2 solutions as an XY pair. So now I'm going to take this 3 and plug it in for this y equals 4x right here that I'm highlighting. So if y equals 4x, I can say, okay, y equals 4x, I know that, but now I know that x equals 3. So instead of y equals 4x, I can say y equals 4 times 3. I'm replacing this x with 3 because I figured out that x is equal to 3. I'm substituting it in. And when I simplify this, I get y equals 12. So I have a coordinate pair at 3, 12. I did not use a graph, I used substitution. I replaced the y with its equivalent of 4x. Let's take a look at another example. So now I have y equals x plus 10 and y equals 4x plus 19. I noticed that y equals x plus 10, so I'm going to underline that and draw an arrow to the y in the other equation. That's telling me, hey, instead of y right here, I'm going to replace it with x plus 10. So I'm going to have x plus 10 equals 4x plus 19. I replaced that y on the left with x plus 10. And now, just like we did earlier in the semester, we're going to solve this. I'm going to subtract 4x on both sides. They cancel. This is like an invisible 1. So I have negative 3x plus 10. Subtract the 10 on both sides. 3x equals 9. Divide both sides by 3. And x equals 3. Now that's one part of my answer. That is my x coordinate. But what am I still missing? My y. So I'm going to take that 3. In fact, I'll make that line red. I'm going to take that 3 right here and look at my original equation, y equals x plus 10, rewrite it. But instead of x, what am I going to put here? I'm going to put a 3. I'm replacing the x with a 3 because I know that I got 3 for my x, so I'm replacing it. Simplify that, and I get y equals 13. So I have a coordinate pair at 3, 13. And that's my solution. All right, let's ramp it up just a little bit in difficulty. So now we've got to recognize something. We've got to recognize which variable is alone. If I look at this first equation right here, I don't have x or y equal to anything. The x and the y are on the same side. I can't get it alone here. That would be too complicated. So I'm going to look at the other equation. And I'm going to notice that, hey, this y right here, he's all alone. So that means I can underline what it's equal to. It's equal to the 8x plus 24 and plug it in for the y in the other equation right here. They're equivalent. So I'm going to rewrite this as negative 7x minus 7, but instead of the y, I'm going to replace it with the 8x plus 24. And what this really does is it makes your solving just a little bit more complicated. Okay, but we're still just going to draw our line and now solve this equation. So the first thing we want to do is distribute. So I'm going to bring down that negative 7x. This becomes 56x, and well, I'm not sure what negative 7 times 24 is. So let's look that up. Negative 7 times 24 gives me 168. So I've got negative 168 equals 21. Negative 7 minus 56x. Let's go check. Negative 7 minus 56. If I can pull up my calculator again here. Negative 7 minus 56. Negative 63. So I've got negative 63x minus 168 equals 21. To get x alone, I'm going to add the 168. So I've got negative 63x equals, let's check in my calculator, what 21 plus 168 is. 189. So this equals 189. Divide both sides by negative 63. Let's check in my calculator. 189 divided by 63, and I get 3. Well, -3 because there's a negative. So now I know the first part of my coordinate pair is -3. Notice I'm showing all my work. I'm keeping nice, neat, and tidy. I can see my work really well and get that answer. Now that I know x is 3, I'm not done. I need to take that 3 here, rewrite one of the equations. I'm going to rewrite the y equals 8x plus 24, the bottom one. But instead of x, instead of 8 times x, I'm going to plug in right here that -3. So now when I find y is going to be equal to -24 plus 24. So y is going to equal 0. And that's okay. You might get an answer of 0. So -3, 0 is my solution to example 2. There's a lot of work here. There's a lot of being precise. There's a lot of making sure we can distribute and solve an equation, get those 2 solutions. These problems do take some time, but we can all do this. We're all very capable of it. Okay. There's also special cases, just like in graphing, where we have no solution or infinite solutions, but it looks a little bit different when we use it algebraically. So I'm going to go ahead and see that this y equals -2x minus 4. I'm going to plug it into the other y. So instead of y here, I'm going to have -2x minus 4 equal to -2x plus 1. I replaced this y right here, and I put it here. I substituted. Now I'm going to go ahead and solve. I'm going to add the 2x to both sides. These cancel and these cancel. So I'm going to bring down that -4, bring down that 1, and ask myself the question, is -4 equal to 1? The answer is no, it's not. So this is no solution. To check our work, let's go ahead and graph each of these. So I'm going to graph the first one in red. So I'm going to start at -4, knowing that I'm going to erase this real quick. Knowing that I'm going to try to erase this real quick. Knowing that when I'm going to put a 1 underneath here. So my slope is up 2 over 1. So up 2 over 1. I'm going to make points all the way through the grid. And connect my line. And then I'm going to graph the other one here in pink. That one starts at +1 and also goes up 2 over 1. Notice they have the same slope. So that should sort of be a clue that, hey, these lines are going to be parallel. They will never intersect. So just like in the previous lesson, this also shows no solution. So no solution graphically and no solution algebraically. Okay. And then we have what looks like infinite solutions. So this example, I've got y equals to 2x minus 1. I'm going to plug it in for the y in the other equation. That arrow is really hard to read, but we're plugging it into that y right there. So instead of -2x plus y, it's going to be -2x plus, and then I'm going to replace it right here with that 2x minus 1 equals -1. So I'm just substituting this guy in right here for the y. I can go ahead and rewrite this without that underline to make it a little easier to see. What is -2x plus 2x? 0. So these cancel out, and I'm just left with -1 equals -1. That is always true. -1 does equal -1. So this is infinite solutions. And we've seen this before when we solved earlier in the year. Okay, if we get the same thing on both sides, it's infinite. Different things that are not equal on the other side, no solution. If I want to graph this, I need to, I'm going to erase the highlight in the red, and I'm going to graph the first line in pink. So I'm going to start at -1 and go up 2 over 1. Make my line. Okay. Now the problem with this one that I'm going to do in green is it's not in y equals mx plus b. So I'm going to rewrite it down here. Negative 2x plus y equals -1. I'm going to add the 2x to the other side. This cancels, and I get y equals 2x minus 1. So then I'm going to plot the -1, noticing that it's the exact same equation. I'm highlighting green. Y equals 2x minus 1. Y equals 2x minus 1. So remember how in the other lesson I talked about the lines will lie on top of each other? That's what I mean here. These lines are identical. They all share the same points that I'm highlighting in green. So these two lines basically just go on top of each other. And we can say this is still infinite solution. That's solving systems by substitution. Okay, I'm going to make sure that you, again, really make sure your work is neat and tidy. You can draw arrows just like I did to help you. You can use highlighters to help yourself, colors, anything that helps keep your work neat and tidy is a really good strategy here. Okay, good luck.